In 3.6, we're going to talk mostly about nonlinear models, and we're going to figure out what these models are using scatter plots and then using the regression feature in our calculators. So if we look at example 1, we have 3 different sets of points and 3 different graphs or scatter plots for these set of points. And we need to pick the one that looks the most linear, the one that looks the most exponential, and the one that looks the most logarithmic. And remember, with your logarithmic, it just is going to look like that log graph that kind of has the curve. So to me, this middle one right here is my logarithmic function. When you look at A, it has that growth curve, so this is probably going to be your exponential. And then the bottom one, choice C, looks linear, so you would probably want to choose that one as your linear model. So once you have your scatter plot and you know or you have an idea of what type of model, then you can use your regression features in your calculator, which, remember, to get there you go to Stat and then Calc, and then you choose your regression. And we'll work on that here in the next couple examples. So when we go to example 2, we have this set of data points. So we have our x and our y. So what we're going to do is you're going to pause this, and in your list 1, you're going to put your x values, and in your list 2, you're going to put your y values. And remember, to get to your list, you go to Stat and then Edit. Okay, so I want you to go to Stat, Edit in your calculator, put all of the x coordinates in list 1, and put all of the y coordinates in list 2. And then once you do that, we are going to look at the scatter plot. So go ahead and pause, put those in, and then press play when you're done. Okay, now that you have your points in, I want you to go to your y equals and make sure that your plot 1 is highlighted and turned on. And if plot 1 is highlighted and turned on, then you can go to your zoom. And once you go into zoom, you can go to zoom stat, and you will get your scatter plots. You'll get a scatter plot for this set of data. Right? And when you look at the scatter plot for this set of data, right, you kind of have this scatter plot that's plotted, and it looks a little bit like maybe it has a curve, but maybe it's linear. So for me, I'm looking at it like maybe it could be logarithmic. So here I'm going to test logarithmic. And I'm going to test linear, because those are kind of the two that look like it could be between. Okay, so to get to your logarithmic regression, you're going to go to your Stat, Calc, and you're going to choose the natural log regression. Okay, so choose Stat, Calc, natural log regression, and your natural log regression has the form y equals a plus b natural log x. Right, so when you do that, we get that our a value is 1.538, our b value is 8.373, and then we have the natural log of x. And here, if we look at our coefficient of determination, we get 0.9935. If we do the same thing for linear, again, remember you go to Stat, Calc, linear regression, and you choose your linear model, which is your y equals ax plus b, we get y equals 2.289x plus 2.336, and we get our coefficient of determination to be 0.9005. So when we look at these two models, they both kind of fit, and if we put these onto our actual scatter plot, they'll kind of both fit. But when you look at this coefficient of determination, this one is just so much closer to 1 than the other one is. So we're going to choose the logarithmic model as our equation that has the best fit. And then on this next example, we have another set of data. So again, what I'm going to have you do is put this in your list 1 for x, and the amount in your list 2 for y. So pause the video while you're doing that. Once you get that in there, create your scatter plot. So create your scatter plot, right? Oops. Scatter plot by going to your zoom and then your zoom stat, and you'll see your scatter plot. Okay, so go ahead, put those points in, create your scatter plot, and then come back to the video. Okay, once you have your scatter plot, what you see is something that kind of looks like this, which to me, when you have that curve coming down, that looks like it could be exponential. So let's check our exponential regression. Right, so we're going to go to our stat, and then calc, and then our exponential regression, which is going to be in the form of y equals ab to the x. So in this case, we get y equals 10.084 times 0.877 to the x, and our coefficient of determination is 0.9988. So pretty strong, right? Pretty close to 1. So we would say that this is probably a really good model. The second part of this is that they want to know how much is left after 15 days. So after 15 days, we want to know what's our y value when x is 15. So we need to put this equation into our y equals, and then go to your table, right, and look at when x is 15. And when x is 15, if we substitute that in, we end up with so when x is 15 and we substitute that in, we get that y is 1.4 grams.